Okay, practice 6, question 1B. Let me check. Okay, what is your problem? Okay.
Find the value of x when tangent is vertical.
Okay, look. This is 2x, 3x plus x squared over x squared minus 5. Okay, when you say vertical tangent, it's possible to have vertical tangent. It means gradient undefined. Okay. Horizontal tangent, it means gradient is 0. Okay. So this is the two situation. So since it's involved gradient, what you need to do, you need to find the derivative, right? dy dx represent the gradient. So you are using the quotient rule. Yeah. V u prime take away u v prime. The whole thing over v squared. Okay, now, so since you are talking about vertical tangent, so g prime x is undefined when x squared minus 5, the whole thing square equal to 0. The bottom equal to 0, that means it will be undefined. So that is the skill that you have to remember. Okay, this one. So now, if I put here, x squared minus 5 equal to 0. So my x squared equal to plus or equal to 5. So my x equal to plus or minus root 5. But x equal to plus or minus root 5 is undefined for gx. This means it's not part of the domain. For gx. So therefore, there isn't a vertical asymptote. Vertical tangent, sorry. Are you clear?
Okay.
So that is how you go. And if we want to talk about further, I would like to put this. Okay, can you all use your calculator, graphic calculator, and try to plot this graph? Can or not? Can you take out your graphic calculator and try to plot this graph? I want to talk about a certain thing. Okay, can you plot the graph? Can you put into your graphic calculator and plot the graph? I'm doing it also now. So I hope if this come out, then you will know what to do. Okay, I have 3x plus x squared. Put into your calculator, please. And x squared minus 5. Okay, so we try to do a zooms. Okay, we try to put our window as since it's root 5 is 2 point something, correct? So we go from -3, maybe -4 to 4. See how it go. Then we do a zoom fit. I'm not sure also, I'm trying. So it looked quite funny. I got one straight line. Is there something wrong with my calculator?
I got like a weird looking graph. I don't think it's a straight
Yeah.
line though.
Yeah, I got like a straight line.
Along like
Okay,
the
never mind.
x-axis, and then it
Yeah.
suddenly shoots up and down.
Oh, suddenly shoot up and down. Oh, I got something else. That's why it make me, yeah. So my window I set, I do a zoom fit. Okay, never mind. I will teach you how to handle it. Okay, yeah, you got a graph, some sort like here. So you have to know how to manipulate. Yeah, Ethan have send the graph. Okay, I have the graph already. We got 2 vertical asymptote. That is negative root 5, right? And another vertical asymptote, x equal to root 5. So when you sketch the graph, this is the thing. So you see, you cannot see the turning point. You also don't know how it goes, right? So what you can do is, after you do a zoom fit, you go to window, please. Go to window. Okay. You go down, you look at your y minimum. Okay, your y minimum. Okay, they give us as -59, correct? You got like that? -59 point something. Okay, so what we want to do is we change this. Maybe we put it to -2. Okay, then your y maximum is equal to 412. So that's why you can't see this region, the region that near 0. Yeah. So 0.696. Okay, we don't want this. So maybe we put about what value do you think? Can someone suggest a value to me? Maybe we put 5. Okay, after you have done that, straight away go to graph. Straight away press graph. Okay, can you please do some changes? The number that I choose is up to you. Okay, then I go to 5, I go to graph. I want to see what happened. So it looked like you don't have a turning point, all right? You don't have a stationary point. The graph go like that. Then go this way, pass through the origin. When x equal to 0, yeah, pass through the origin. Okay, then it passed through here, -3, I think so. All right, and it go this way. There is a horizontal asymptote. Am I right? There is a horizontal asymptote. There is a horizontal asymptote. Okay, so you go like that. So the question they may ask, why there isn't any inflection point. So if they ask why there isn't any inflection point, how are you going to answer? Yeah, there is a change of, is there an inflection point? Yeah, there is one here. Oh, sorry, there is one here. Okay, why there is only one inflection point? Okay, why there is only one inflection point? Okay, how are you going to base on this graph? Why there is only one inflection point. Then how are you going to answer? The shape of the graph changes, correct? From here, this part A is concave, what? Upward. Right? This part B is concave. Let me finish writing concave downward. And this part C is concave upward. So there is a change of shape here. So here there is one inflection point. Why here don't have? Why here don't have? Why here doesn't have? Why here doesn't have? Can someone tell me? So someone have given me the answer, I believe, in the chat group. There is only one inflection point where the concavity of the curve changes. Yeah. When it is from the convex to concave. Why there is only one? Here also, why this one over here don't have? It should have three. And part D here, you see, is concave downward. So how are you going to answer this part? Why no? Okay. So you look, the concavity change at where? The vertical asymptote. That's why there's no inflection point, because there's no continuity of the graph across the vertical asymptote. Are you clear? Because the concavity changes at the vertical asymptote. Where the function is undefined. This is one of the past year questions. Are you clear? So that's why there's no inflection point. There's only one. Are you okay? So if this question happen to come out, then you will know how to answer. Are you okay? Yeah. So that is how you give the answer. Because there's two parts whereby the concavity changes at the vertical asymptote. Yeah. Can or not?
Okay.
Okay. Wait, yeah, someone has. When we plot the graph, why do we highlight? Why you highlight plot one? You shouldn't. You should unhighlight it so that the plot one won't be in. When you plot your graph, make sure only the equal sign of the graph that you want to plot is highlighted. Like I got a lot of things, correct? Okay. I show you my calculator. I got a lot of things. You see, only the one that I want to plot is highlighted. Are you clear? Hello? Do I need to show? I think I don't have to show. You should be able to know, correct? So you just put your cursor to the equal sign of the one that is highlighted. You just put an enter, then it will be unhighlighted. So that means you don't want the graph. Anyone, plot 1, plot 2, plot 3 also, you have to check. If not, you will have a lot of problem with it. Just now I got a problem because one of my unwanted graph, the equal sign is highlighted. Okay, no more question? Okay, so this is a search function. So this is a local maximum. And this local maximum, we know that the formula is -1 over b, correct? Here, 1 over b. So it's 1 over b. Yeah, so then this one is just put in 1 over b, then you will get the, so this is a over be. Sorry, be, right? So this is a local maximum, but look, okay, but it is also global maximum. How I know it is also a global maximum? The reason is because I say as x approaches infinity, my e to the power negative x approaches 0, and my y, which is ax e to the power negative x bx, will approach, because this is 0, so it will approach 0 also. And as x approaches negative infinity, there is this side. Okay, my e to the power negative x will approach infinity. Yeah, because negative times negative, you got positive. So therefore, my y, which is ax e to the power negative bx, this is negative infinity. This is infinity. So you multiply, you got negative infinity. So it doesn't go up anymore. So therefore, this is also a global maximum. So therefore, the range will be y. Y is a member of real number, and y is always less than or equal to a over be. That is how you do. So I cannot tell you exactly how is it. First of all, you have to get the turning point. Then you have to study the feature. Hello? Okay or not? If the question wants you to find the range, usually the question will ask you to find the stationary point first. Then describe the nature of the stationary point. Then they will ask you to study what happened to y when x approaches infinity and negative infinity. These are the things that they will ask you to do. So you just follow what the question wants you to do. Then you follow, then you will know how to answer for the value of range. Okay? Okay, this is a search function. Still remember, I asked you to record down in the search function. Yeah, the coordinate x of the turning point. You can do it. You can straight away apply for this one. You understand what I mean? That means you should put this one down in your notes. Like for example, if I give you a function y equal to 5x e to the power negative 0.3x. So I can know the local maximum. By just using the formula 1 over, this is your B. You don't include the negative. So 0.3. Yeah. So this is 10 over 3. Okay. Then the y coordinate will be your A is 5 and your B is 0.3 E. So this will be 50 over 3E. So you can know straight away. And still remember the inflection point, 2 over B. Yeah. So you will know that this is a special function. So you should record this one down in your notes. Okay, another special function is the search function. Okay, still remember the one that I asked you to record down, the search function and the logistic function. Yeah. So the logistic function, the shape of the graph is S shape. And this is the maximum. This is the upper limit. So the y will not go beyond. So this one you also can find the range. So this is your y equal to c. So that means the range will be y is a member of real number and y is greater than 0 but less than c. So greater than 0 but less than c. So this is for logistic function. And the inflection point happen at this one is c, this one is halfway, c over 2. Only for this type, other type may not. So you have to be very careful. And the dy dx graph, the dy dx graph will be going some sort like increasing. So this should be the inflection point. So this is the maximum. So the dy dx graph will go like that. This is your dy dx graph. Okay. And the coordinate x, do you have the value? Anyone have the value? Ethan, do you have the value for coordinate x of the inflection point? Do you put down in your notes?
For the x for the search function.
No, this is a logistic.
Non-A over B.
You didn't put down. Okay, so never mind. I will just do some calculation. C over 2 equal to C over 1 plus A e to the power negative bx, okay? So C and C cancel. So 1 equal to A e to the power negative bx. 1 equal to A over e to the power bx. It's better to do it like that. E to the power bx is equal to A. So your bx will be equal to ln A. So this is ln A over B. So it's good to write it down. So that when you need to use it, you see it like that, then you will know what to do. Only if the case is C over 2, halfway, if not, you cannot. You have to use your GC to get the inflection point by plotting the dy over dx graph. Are you clear? Okay, anything else? Oh, okay. Thank you, Ethan. So you get prepared all this in your notes, correct? Then
P asterisk can be P asterisk
So-
can be the population proportion.
so depend. So if I plot the graph for this one, y equal to, I take this as a constant, x 1 minus x. Okay, sorry, 1 minus x, correct? Okay, so we get this idea first. So the graph will go in this way, am I right? And you know that P, the value is highest is 0, lowest is 1, am I right? So the graph is only here, this part. So it's a quadratic. And here is a 0.5. So you see, your maximum number of sample size happen when the proportion is 0.5. So this is your n maximum. It will not go beyond that. So which value of P to choose depend. P naught also can. Your P asterisk can be your P naught. Your P asterisk can be your P hat. So if you don't know your P naught, if you don't know your P hat, then you use your P asterisk as 0.5. This is population proportion. Okay, I should put it like that. Instead of say population proportion, I will say that all population proportion. Okay, this is the sample proportion. If you don't have this, you want to make a judgment of how big the sample size should be, then you use 0.5 because the sample size will not go beyond this number. That is the nature about prediction of the selection of the sample size for anything that you want to study about proportion. But if the proportion, the all population proportion, is an outdated value, then you shouldn't use it. Like for example, I talk about proportion of people who have Facebook account in year 1990. So the proportion is very low. So that is outdated information. Understand? Outdated information, like for example, there's a lot of outdated information, like talk about corona. Okay, this is out of the topic. Anyone try to plot the graph for f prime x for this? Okay, I got it down. The f prime x graph that I got. Okay, so it go like that. So exam, they can ask you, so you see all these are going down. So definitely it's negative. All right. And this one is going down as well. So it's negative. So this is a non-horizontal inflection point. You go like that. And for the other one, you go this way. So this is your y equal to g prime x graph. So they can give you a fx graph like that. Okay, gx graph like that. Then they ask you to sketch the g prime x graph. And they ask you to find the coordinate of the inflection point. Yep. Okay. So this is another extra thing that it may ask. So when you do your revision, correct? When you go through, correct? When you talk about this, you try to explore into more. Clear? Hello? Okay, so I leave it to you. Since I'm sitting here. Okay, any more question?